Welcome and thank you for joining. Let's take a look at another trig equation, and this time we have 2 secant squared x minus 3 plus 10x equals 0. As you can see, this is a quadratic trig equation because the secant ratio is brought to the power of 2. So first, let's take care of the trigonometric ratios in the equation. As you can see, we have secant and tan, and we prefer to have a single trig ratio throughout the equation. So we have to think of a formula or a connection between secant and tan. And if you remember, one of the Pythagorean identities states that 1 plus tan squared x equals secant squared x. And this will allow us to replace the secant squared x in the equation by its equivalent 1 plus tan squared x. Now remember that 1 plus tan squared x is in binomial form, which means that we need to keep it inside the brackets to ensure that we're multiplying by 2 the entire expression that represents a secant squared. So 1 plus tan squared x here. And the rest of the expression is as is equals 0. Now let's expand and simplify. So 2 times 1, 2 times tan squared x will give 2 plus 2 tan squared x, and then we have minus 3, and then plus 10x equals 0. Let's rearrange the terms from highest to lowest degree, and this is because, as you can see here, this is a quadratic equation, and quadratic equations are solved by first taking all the terms to one side and leaving 0 on the other. So 2 minus 3 is negative 1 equals 0. Now, here I'm going to explain something that we mentioned in the rest of the examples we've discussed in class. For some people, it's useful to replace the ratio, the unknown ratio 10x, that's the one we're solving for, by an unknown variable a, and that is only because it makes the equation friendlier and easier to solve. But it's not a must-do step. So I will show this with the helping variable a in this case. So we have 2a squared plus a minus 1 equals 0. And now let's factor. So we are solving this as a polynomial equation first. So this will factor into, we have 2a and a. This is what gives the 2a squared. And two numbers that multiply to negative 1 and give a sum of positive 1 for the middle term would be negative 1 and positive 1. So double check, 2a squared plus 2a minus a will give the plus a, and then minus 1 times positive 1 is negative 1. Now this product will be equal to 0 if either factor is 0. So that means a must be half or negative 1. Now let's bring back the 10x ratio. So we'll say 10x equals 1/2 or 10x equals negative 1. Now we're going to solve these mini trig equations simply by using the calculator. We'll get x equals inverse tan, 1 over 2. And as you can see here, 1 over 2 is not a special tan ratio, which means that we cannot get the exact answer, which means again that we have to round the answer, which must be in radians, and we know that all angles in radians must be rounded at least to 2 decimal places. So inverse tan 1 over 2, set your calculator to radian mode. And so for tans, the second tan, 0.5 or 1 over 2 will give 0.46 radians. So this is our first solution here. And for the next equation, 10x equals negative 1, we have x inverse tan negative 1. And if you use the calculator, again, this is a special ratio of negative 1. And if you use the calculator, it will give you the angle in degree mode, 135 degrees, which converts to 3 pi over 4 radians. So we'll get both angles and draw them on the Cartesian plane. So remember 0.46 radians first would be half a radian. A radian is about 60 degrees, so half a radian would be less than 30 degrees, so it will be an acute angle down here. And since we're using the 10 ratio, we will build the second angle by extending the terminal arm. And something similar would happen with the angle 3 pi over 4. So for angle 3 pi over 4, we'll have this angle, and you build the second angle by extending the terminal arm down here. So let's read all these angles. I'm going to make this a little bigger. So here goes the angle 0.46 radians. And here goes the angle 3 pi over 4 radians. Whenever possible, we must write the solutions in exact form. So we're going to say that x equals 0.46 or x equals 3 pi over 4. And now let's read the green angle. So here we go. We have 0.46 plus pi radian. So since in this case we have rounded the answers to 2 decimal places, when you add pi radian, we'll do the same. So 0.46 plus pi would equals 3.60. Similarly, we're going to find the angle x that we obtained from the second factor. And as you can see here, we have 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4. So you can just read the angle of the Cartesian plane. So here we go. We got all the answers. So the first one, 0.46. And then we have 3 pi over 4. We have the angle 3.60 radians and the angle 7 pi over 4. So from the graphical point of view, what we do here is we graph the left side of the equation. So you type up the equation as is on decimals, and this is the graph you obtain. And then you graph you type the equation y equals 0, which is the right side. And we know that this would be the x-axis. As you can see in here, the solutions are at the indicated point. So 4 solutions. So 3 pi over 4, 7 pi over 4. And then these 2 angles, which are rounded to 2 decimals. We did, but the calculator here showed 3 decimals. So I hope this made sense, and I invite you to try the next example on your own. Thank you for watching. Bye for now.